Hi, everybody. Our team is partnered with US EPA to research combined sewer overflows in the Puget Sound region of Washington. Okay, so as some background, all of the water that we use in our day-to-day lives, in our showers, our sinks, our toilets, this all needs to be processed and treated, and so it's transported to wastewater treatment plants. At the same time, stormwater produces precipitation that goes from our roofs, through our sidewalks and roads and parking garages. And to prevent flooding, some of this also needs to be transported away to wastewater treatment plants. In newer cities, this is transported separately. So sewage is transported in one set of pipes, and rainfall, precipitation, that's all carried in another set of pipes. However, there are problems in some older cities, mostly on the East Coast and a few on the West Coast, where all of this is carried in the same set of pipes. All of the water that we use, our sewage and our stormwater, is carried together to the wastewater treatment plant. This can create problems during storms, during periods of heavy precipitation, because these systems are overwhelmed by the combined volume, and this can lead to what we call a combined sewer overflow, or a CSO. So this is when all of the raw sewage and untreated stormwater is just dumped into our oceans, it's dumped into our rivers and our public waters. This can lead to many human and environmental health concerns. It can contaminate the beaches where we swim. It can contaminate shellfish beds and fisheries. And so this is the basis of our work. This is why we care. There's a gap in research. There hasn't been a lot of recent research on this topic. The EPA hasn't covered this since a report that they published in 2004. So we are aiming to fill critical research gaps with regard to the impacts and patterns of CSOs. And we structured this around these three main topics, which are volume and frequency trends, recreational and commercial impacts, and the impacts of climate change on CSOs. We focus on the Puget Sound region of Washington because this is the largest estuary in the continental US. So this is a very valuable marine ecosystem that we want to conserve and protect. Also, this is home to a few large cities, namely Seattle and a few others around the region. So there is that, there's a larger risk of human health impacts. As you can see on this map, these are the cities that we chose to focus on, including Bellingham, Anacortes, Port Angeles, Everett, Seattle, Bremerton, and throughout King County. And for our deliverables, we're producing a comprehensive report, a story map, and an online database of all of our data and resources, which we will give to our stakeholder.
So for our first analysis, we did a frequency versus volume mapping to just see the trends of per jurisdiction on these events and to really be able to look at hotspots and problem areas. If you see, this is a map of a spatial map of Seattle showing CSO events and volume per month from 2009 to 2023. So you can see the hotspots in this area, also volume depicted by size of the red dots. Each of these red dots is the time that sewage spilled into an open waterway. I think we can all agree that's extremely gross. And we're also seeing that it's really high during the 2009, and we are seeing a slight decrease as we get closer to 2023. We're seeing a lot of it happening in this Lake Washington Canal hotspot that we've highlighted during wet months, which is like winter, spring, and fall. And then sometimes it is just kind of all over the place. But overall, we are also seeing smaller dots as we get closer to present day. We also did an analysis of volume versus frequency on an annual scale. So if you want to look at Seattle right here, we're seeing the frequency and volume map. Frequency is depicted in with the orange line, and then volume is going to be these blue bar charts. So the peak of Seattle's frequency was in 2014 with 800 events happening that year. Mind you, this is 800 times that sewage was released into the waterways. It's disgusting. We are seeing that the lowest was in 2019 with about 100 events, which is a great improvement, but that's still a lot of times that this has happened. Overall, we're seeing that Seattle does have a decline in volume and a decline in frequency over the past 15 or so years, which is really good. And we're seeing that pattern in other cases or other jurisdictions we look at as well. For the case of King County, which makes up a very similar jurisdiction as Seattle, we're only seeing a decrease in frequency, not in volume. This led us to see that volume and frequency are not necessarily correlated. So meaning that when there's a lot of volume doesn't necessarily mean a lot of events and vice versa. This just kind of showed us that there's a gap in information at what really leads to these events, and more research needs to be done.
And as I mentioned in the introduction, combined sewer systems carry stormwater and sewage together in one set of pipes. So because of this, we wanted to look into cumulative precipitation and how that affects the frequency and volume of CSOs. This is an example in Everett, where you can see the green squares and the orange diamonds represents times where CSO events occurred. And then the blue lines are cumulative precipitation, which is just the total precipitation that happens during any given storm. And then the dashed lines are at the bottom are the average threshold for where CSO events occurred. Basically, what we can take away from this is that we didn't find really any correlation between cumulative precipitation and when a CSO event occurs. This, from talking to experts, we found could be due to mechanical errors or scheduled maintenance. But we really just needed more data that was not accessible to do with like the volume that these pipes can hold and the rate at which this is processed.
Okay, so now onto our second point of analysis, which is looking at how recreational and commercial consequences are being impacted by CSO events in the Puget Sound. And so from this map, you can clearly see that there are a lot of CSO events happening in this area. So on the map, you can see that the triangles represent CSO sites and the circles represent beach access. And I don't know about you guys, but that is a lot of CSO events. People are literally swimming and consuming sewage. And so because of this, we're specifically going to look at the case study of beaches and specifically CSOs within a half mile of this area. So in order to conduct this analysis, we decided to look into specifically the summer months, as this is when activity of beachgoers is the highest. And so we compared the jurisdictional trends between all the cities here. And just to point out an example, we can see that the highest was around 2013 for Seattle with about 47 CSO events. But cumulatively, in just this year alone, there were 122 events. And that's just in 1 year. As you can see, these numbers can definitely add up over time. And however, we can also see though, that's important to notice that there is a decrease that happens in 2015. And specifically after the spike of 2013, there were infrastructure and policy changes that happened in Seattle and King County, which could potentially lead to this decrease that happened in 2015.
So our third analysis focused on how climate change is going to impact future occurrence of CSOs. So we used NOAA's intermediate to high sea level rise scenario, which plans for higher emission pathways and is a recommended scenario, for long-term infrastructure planning. And our modeling showed that 28 CSO outfalls were vulnerable to flooding from sea level rise, which can cause backups and corrosion damage to pipes if saltwater enters the sewer system. In addition to sea level rise, climate change models also predict higher precipitation. A 1 in 100-year flood event is predicted to become a 1 in 18-year flood event by 2100, which can overwhelm sewer system when they get an overwhelming amount of rain in one day and more intense precipitation. And we also wanted to look at how different populations will be impacted by flooding and CSOs. So we created this socially modified vulnerability score map, which correlates 3 factors: exposure to sea level rise and erosion, the sensitivity of the habitat, so in the estuary, what kind of biodiversity is there, and the social vulnerability of the population living there. And we see that this is something that cities have been taking into account when prioritizing their CSO projects. And throughout our project, we also looked at how cities were planning to incorporate for climate change in their CSO control measures. So were they building new storage tanks, were they retrofitting their pipes to deal with backflows or saltwater intrusion? And that was also a large part of our project. Thank you.
Just for those of you who are concerned, LA does not have a combined sewer system. Any questions?
How can the city of Seattle, like that area of the Pacific Northwest at large, address the concerns that they have about like the mixing food?
So there's different types of methods. A big one from talking to experts is more investments in green infrastructure and trying to make sure that how can we keep water from entering the sewer system in the first place? Like Grace was saying, when we have stormwater in addition to the water from our showers and all of that, that's what overwhelms the system. So if we can make the soils more permeable, have more just like restore our wetlands, have more rain gardens, more especially in low-lying industrial areas, just make sure that we can get water absorbed into the soil so that it doesn't go into the sewer system. That would be a great addition to, of course, like you have to upgrade your infrastructure, maintain your infrastructure, and that's costly. But yeah, it's kind of a combination of more storage, better treatment facilities, and just reducing the amount of water that goes into the sewer system through green infrastructure. I would say those three.
Any other questions? One more. Oh, sorry. Yeah, sorry. No, please. Yeah.
I was just say, was there any evidence of like illnesses? Like were people, like the percent concentrations were so high that people in certain communities were actually getting sick from, say, the sewage they might be exposed to?
Yeah, so the problem with combined sewer overflows and tracking the sickness is that these are in, urban areas where there are many sources of pollution. So it's really hard to track between, if an illness was caused from a CSO or, some other source of pollution. There is preliminary research that suggests that a lot of the pathogens and chemicals that are found in CSOs cause illnesses. So there is that correlation, but there's not often direct causation.
Thank you so much, team.